Hello there and welcome to my workshop and another fiber laser tutorial. And this week we're going to do a little bit of deep engraving on some nice stainless steel. Look, I just purchased this butcher's knife, I suppose you'd call it. It is the cheapest way that you can get fairly good quality stainless steel. I mean, this cost me $4. Yeah, if I wanted to buy a piece of stainless steel, nice, good, clean quality stainless steel, it would cost me 4 or 5 times that. So I'm just using this knife for the material because it's got a handle on it and we need to keep it absolutely flat. I've just got a piece of MDF, put a couple of screws in it, so I've got a reference point where I can put it up against, and I've got some bolts in the bed here which make a straight line somewhere for me to put this up against, and I can replicate that every time if I wish. And it just holds it steady, not that there's any vibration or anything like that with a CO2 laser. That's another thing too. A CO2 laser under 150 watts output will not engrave or mark any steel whatsoever. You can paint it and remove the paint, or you can coat it in a ceramic type paint and melt the ceramic paint onto the metal, but you cannot remove metal with a CO2 laser. You would need a CO2 laser of above and well above 150 watts to do any cutting or engraving in any metal whatsoever. In fact, I would suggest if you wanted to use a CO2 glass tube laser for steel engraving, you would need 300 watts, which is a very, very expensive machine. So this is why I have turned to a fiber laser. This fiber laser maximum output or peak output is 25 kilowatts. That's why it can engrave and remove, and you don't really use it for cutting, steel or aluminium. Aluminium is very difficult to actually engrave or do anything with any type of laser because it is so reflective. So what I'm going to engrave is just this simple Batman emblem. It's 40 millimeter in length, and I think about an inch 25 millimeter in height. So I'll bring you in for a closer look of what I've set the laser settings at. This is the setup wizard combined with this one here. Now with a fiber laser it is totally different to any other type of laser actually. So what I've done here is hatch 1. In other words, a hatch is the series of scan lines that the laser is going to scan through this object. So a hatch is a series of scan lines. So in hatch number 1, I've enabled it. All calc just means that the laser is going to start here, fire in this black area, switch off, then start firing again all the way through, and so on and so forth. And it will do it in one complete line. Okay? It's not going to start up, switch on, switch off, and then go in a different area. It's going to continue in a straight line. That's what this actually means. Zero angle, so in other words, it's going to start here, it's going to work its way up through the picture. It's on a black layer. We'll come to the layer in a minute. And the step over scan line is 0.01 of a millimeter, which is a very, very small amount. In actual fact, you'd be hard pushed to actually see the scan line itself. Okay, so in hatch 2, which is enabled again, I am scanning 45 degrees angle through the picture. That's the only difference there, same scan line width, and hatch 3 is minus 45, so in other words it's going to scan this direction. It's always good to, with a fiber laser, to, if you're doing a deep engraving, is to have the scan lines separated, coming from different angles. And in all cases of the scan lines then, the power is, first of all, the speed of the scan line is 250 millimeters per second. I'm running a 90% output, so that's going to be a peak power of about 22 kilowatts, around about that. And the frequency is 20. That's the 20 kilohertz, that is. We will, as we progress through this, I will be altering the power, the speed, and the frequency, and I'll show you what different scanning process and what the result is in the engraving. Okay, so we will light this first to see where it's actually going to engrave it exactly. So put the red light on, and it's going to be right there in the middle. Okay. So we'll put it right on the end there, because I'm probably going to do 2, 3. Don't want to waste too much material. That will be just fine there. So let's start to engrave with the fiber laser. I actually missed a very crucial point there, and that is focus the laser. I actually forgot that I had this stepped up just over ½ an inch. So, simple job is to raise up the head, and in this case it needs to be, let me see, the bottom of the lens needs to be pretty well exactly 168.5 millimeters above the material. Otherwise, as you just saw, it will do absolutely nothing. Okay, so here we go. And this is going to run 3 passes at different angles. So let's see what it'll do. What I'm actually after here is a perfect engraving. I want an engraving about 2 or 3 thousandths of an inch deep, maybe a little bit deeper, but I'm after a perfect black engraving down in the base. So that's what I'm looking for. So here we go. It's just red like that. Yep, I'll have it just there. and let's engrave. I'll fetch you in for a closer look of that. And that, of course, is a perfect, permanent, black engraved, engraving or mark into stainless steel. It's still a bit warm, actually. Yeah, it's still quite hot. It's approximately 2/1000 of an inch deep, which isn't bad for 3 passes. And as you can see, it's a perfect black engraving. And I don't know whether you noticed as the laser was scanning, all the sparks coming off. Of course, that was the laser actually removing the material and burning it up. And because I know there's 2 camps of the main superheroes, I'd better do a Superman emblem as well. So we've highlighted this and we've got it in the center of our viewing window. So we're going to bring up the hatch and we're going to go the first hatch. We're going to do this one slightly different. We'll keep it the same scan line, but this time we're going to go with a rotational, scan line for the first hatch. I don't know what difference that's going to make, but we're soon going to find out. Second, I'll leave it on the normal type of single scan line. No, I'll tell you what, we'll do a double scan line, back and forth, back and forth. 45 degrees out, and then we'll come back to the normal type scan line just to see what difference it makes. So we'll OK that, and we'll just, yep, let's spring that up and just have another look. So 1, yes, I'm happy with that. 0 degrees because it's a rotational scan line, so we're going to apply that just to make sure. Second one, 45 degrees out, and we'll apply that one just to make sure, and the third one, minus 45, and we'll apply that one. Okay, so we've got that done. So now we're going to come over here and we're going to choose our power. Let's see if we can go, let's untick that. We don't want the standard settings. I'm going to go with 500. And I'm going to go with 90% power. I'm going to go 25 kilohertz, just to see what the difference is going to be, whether it's going to be a grayer outcome, or whether indeed it will do a as good a dark mark or engraving as it did with the Batman. So let's set up and give that a go. Okay, so we'll red mark that. I'm going to put my glasses on first. Always wear protective glasses, especially with a fibre laser. So we're going to red mark that. That's going to be just fine there. So we'll stop that. So here we go with our mark, and let's see what the laser makes of this. Not bad at all. I'll just bring you in for a quick look at that. So it's not as dark. You can detect that it's not as dark as that, but it's pretty close. And it took half the time. Maybe, well, it's not even worth doing it twice. So, I mean, this is a very, very reasonable mark, actually. It's a very good mark. I don't know, it's still warm. It's about half as deep as that one. But it has removed material, but you can just detect it with your finger. But this one is, yeah, there's no going past it. That one has removed material quite a bit. And I'll just remind you that these marks, they are etchings. There's material removed with a fibre laser, and the colorization, the black, is permanent. It's not, it's not going to wear off. It's not going to rust. It's absolutely permanent. And I hope you've enjoyed this very short, simple demonstration of how to really just import a piece of art into Easy CAD. In this case, I used Carveco Maker Plus to make the vector lines from a drawing, and brought it straight into Easy CAD and set the laser settings very easily, and perfect outcome every time. If you get the settings right, as in the power, the scan lines, it's a very, very simple laser to use. I must stress that you must be absolutely focused. I think earlier on I did mistakenly demonstrate that if you're not in focus, the laser does nothing or very little. And in this case it was what, 16 millimeters out of focus. And I think I showed you bringing it into focus, you know, it sort of intensifies right up. You have about 0.5 millimeter either side of that. In other words, you can defocus it 0.5 millimeter up and 0.5 millimeter down. And, you know, you sort of can get in the middle there, really by watching the, you know, the intensity of the laser on the material. But you can roughly measure it, and I know that to measure from the underside of this lens lip to the top of the material needs to be 168.5 millimeters, and that is for this lens. Okay, and this is a 110 millimeter focal lens, so that's, you know, sort of a square about that big. But the other lens I have down there is a 200 millimeter lens, so it's a 200 millimeter square, and it will do anything in that area. I have noticed that right out at the very extremities of that operating window, then the focus window, it tends to just tail off a little bit. And of course, with the larger focal lens, you have to to get the same effect. You just have to up the power just that little bit more. Where I was using 90% for this, I would need to use 95%. Couple of things with lasers too. Now we're on about percentage of output. I know a lot of people have mentioned to me, oh, but this is only a 30 watt laser, diode laser. It's not. Strictly true, yeah. There is multiple diode lasers inside that cabinet. In this particular case, I think there is it's either 9 or 12. I think it might be 12. There's 9 secondary diode lasers, and there's 3 primaries. I will go into detail over the coming months of how that actually operates, but basically the secondary lasers sort of put the laser power into the amplifier, and the primary lasers do the firing then. Okay, it's quite complex, but I'll try and get a way of explaining it easier, you know, on a board or something like that with a diagram. So the 3 primary lasers in there are the control lasers, and the secondary lasers in there are the power feed lasers, if I put it that way. And like I say, it's got a built-in amplifier. So initially there's 30 watts of laser power, but then that goes through an amplifier, which, you know, sort of over a period of time, and this laser works in billionths of seconds, not millions of seconds like the CO2 laser. This one works in billionths of seconds. So it charges up over a very, very short time, and then releases the laser energy very quickly. And that's why it can put out a peak power of 25 kilowatts peak. That's how it can remove steel and aluminium and gold and whatever you put under it. And another very important consideration with lasers. Now, the best CO2 lasers, the tubes, like a recce tube, will have a lifespan of between 10 and 12,000 hours, depending on the model type. If you have a no-name brand laser tube, you're going to be lucky to get 3,000 hours of life out of it. Now, that's not 3,000 hours of actual usable, using the tube. That is 3,000 hours period of time from when it was manufactured. Okay, they have a lifespan. The lifespan of this particular fiber laser, 30 watt industrial fiber laser, and I will stress 30 watt industrial fiber laser, is 100,000 hours. That's the difference. So the lifespan of this particular laser is 100,000 hours. It's going to outlast me, I think. And the operating window with it depends on what lens you have in it. Okay, I have two lenses. They're not cheap. Okay, each one of these lenses is approximately $350 US. The unit itself, the fiber laser, is upwards of $5,000 US. So it's not a cheap item, right? It's not a cheap laser. But it is, if you wanted to make jewelry or engrave photographs into metal or etch designs into metal, any metal, this is the laser to get, not a CO2 glass tube laser. A CO2 glass tube laser to do this type of work is going to cost you $30,000. That's why I've gone to a fiber laser. So I hope you found this little video interesting today, and I'm going to actually up the ante quite a bit. I think next week we're actually going to be making a design into, I'll just go and get it a second. This is a fairly expensive Zippo lighter. It's all brass, it's solid brass, and I've got a request to actually etch a particular design into the four faces of this. So that's one of the jobs we're going to be doing next week. So on that note, I hope you have enjoyed this one, and I hope you join me on the next one. Different material, different type of engraving, And we're actually going to be doing some polish engraving as well using the fiber laser. So don't forget, below this video you will find a pretty hefty discount code for any of the Carveco programs, which I would suggest is probably the best program to use because of its 3D ability as well, because you can 3D engrave with this as well, which we will be doing in the future. Plus the 2.5D engraving, which that's what this is, 2.5D engraving, and its ability to make vectors out of any type of drawing. And for those of you who do like what I'm doing, you may consider becoming a patron to the channel, because it is the patrons behind the channel that actually keep it afloat, keep it going. So thank you for joining me, and until next time, bye for now.